All right, welcome. This video is going to walk you through the parent graph equations that we worked with earlier this year. There are 8 of them total. We have parabolas, hyperbolas, exponentials, cubics, Sleeping parabolas, absolute values, circles, and square root graphs. Now, as we get going along these equations, you're going to notice there are 3 parts to the equation. You have to understand that there's an h part. That's your horizontal shift. Whatever you see in parentheses with the h, or with the x, that's going to be your horizontal shifting of the locator point. To also remember that if it says x minus, that makes it go to the right. If it says x plus, it's going to make the graph go to the left. There's also the vertical component of the k value. Whatever you have after your equation written here as a plus or minus value, that's actually what it's going to do. So if it says plus something, it moves the graph up. If it says minus something at the end, it'll move the graph down. And lastly, the a value, the stretch factor. What does that number do to the graph? Well, you can find it by looking at the locator point first and then going 1 square to the right and then counting the number of squares it is to get to the graph. Sometimes you count up to get the graph value, or to get to the graph. That makes a positive a value. Sometimes you'll go to the locator point and you'll go to the right and you'll go down some distance. And that distance, again, is the a value to the graph, and it can be negative as well. There is one special one, though, that's exponentials. Exponentials, the locator point is right there, and you'll find that the a value is found directly above it, the distance it is to the graph. So let's look through some examples real quick here to get your memory refreshed in this area, and here's how these work. So let's look at this exponential equation here first. As you notice, there are 2 dots. The locator point is the one that you see down here on the asymptote. That distance to the graph is your a value. So you'll notice from -4 to +2, that's 6 values, or 6 units. That makes the a value then 6. We're going to always have a 2 for our base, and then the exponent being x minus 1. That's because your locator point goes 1 right and also down 4, and that's why you also see the -4 there for that dot as well. When you're making this on the actual computer, if you had this equation to make, it's 3 clicks. You'll make the first click for the locator point, then a click that's directly above it, the a distance, then you go over a square and you do that a distance again. So you do the a distance twice on exponentials when making the graph. All right, next, if you're talking about parabolas, you'll notice that the vertex is the locator point of this graph. And if you go 1 square to the right, like we talked about earlier, that distance to the graph is your a value. You'll notice it is 2 squares to the graph. So therefore, when you write the equation, it'll be y equals 2, and then x minus 4 squared, because the graph went to the right. So you're seeing x minus 4 squared, and then -3 at the end to get the vertex to go down 3 squares. Hopefully this is not too hard to do as you see these examples here. Next, we got cubics. This point of inflection is that place where the graph starts to swerve. And it happens here at 4 to the right and down 3. So if you're going to make that graph, you'll notice it has, again, an a value that's 2. That's because it's going 2 units up when you go 1 square to the right. And then the rest of it is -4 and a plus and a -3 because the graph went to the right 4 and then also down 3. But again, as you're remembering this, it's always opposite with the parentheses, and you keep the number the way it is as you see it moving up and down. So since it went down 3, you put a -3 there. Hyperbolas work the exact same way. The locator point is where the 2 asymptotes cross, here at -3, 2. And you'll notice here it only goes up 1 square. So your a value will be this 1 that you see in the top of the fraction instead of some other number. And then the next thing you'll just need to notice is that it went 3 to the right, 3 to the left. So you see x plus 3, and since it went up 2, and hopefully you're starting to see a pattern here of how all these things move. This V-shaped graph, just to refresh your memory again, is an absolute value graph. You'll have to press Shift, and then above your return key is the vertical bars when writing the equation. This graph goes 3 to the left, and it also goes up 1. Notice we did not write a number in the front because the a value here, when you go 1 square to the right, is up 1 unit. When it is 1, with the exception of hyperbolas, you're not going to have to write the 1 for the a value. Next, sleeping parabolas. Don't forget the plus or minus that goes in front of the equation. Your a value again here in this one here is only up 1 square when going 1 to the right. If it does go 2 to the left, you'll say x plus 2 and then -3. Lastly, circles. This is the one that's unique. It actually has parentheses around the x and the y when writing the equation. So when you write the parentheses around the x, as you have for all the other parent graphs, it'll be opposite for the x. However, for the y, it is opposite for the y part as well. So be aware that y plus 2 is because this graph is going down 2. Finally, this last number right here represents the radius after it's been squared. So you've squared the radius to get 16, so the number that you would have squared to get 16 is the number 4, and that's your radius. So if you see a radius of 4, remember today when you're writing your equation, make sure you square it to say that it equals 16 or some other number that your radius is squared. Last thing is looking at circle graphs and so on. That's going to go the other direction as well. So make sure you can also make the graphs when seeing the information on the paper as well. So today, go to the parent graph equation assignment. You'll see it as TT number 3A, and I wish you the best of luck, and hopefully it is not too difficult to get through your parent graph equations. Good luck today.